Before delving into the announcement, it's essential to first comprehend the significance of particle accelerators. The Large Hadron Collider, LHC, managed by CERN, is a 17-mile ring made of superconducting magnets and stands as the most colossal and powerful particle accelerator in the world. It epitomizes the zenith of human scientific achievement. In fact, it's so potent that it can replicate the very conditions that existed at the universe's birth. However, could this instrument, which was created to uncover the universe's secrets, also be a gateway to something far more dangerous? CERN, which was established in 1954, is one of the most renowned research institutions globally, consisting of 23 member countries and thousands of scientists. It serves as a central hub for collaboration and innovation. The LHC is its flagship project, but it's just one part of an expansive network of accelerators and experiments. Imagine a racecourse, not for cars or horses, but for subatomic particles racing against time and space itself. The LHC propels protons to nearly light speed, guiding them into a collision path that replicates the energy present at the universe's inception. These collisions generate temperatures millions of times hotter than the sun's core. Thousands of magnets direct the protons as intricate cooling systems maintain the magnets at temperatures colder than those found in space. The beams inside the LHC are designed to collide at 4 points around the accelerator ring, each corresponding to a different particle detector: Atlas, CMS, ALICE, and LHCb. These detectors each serve a distinct function, exploring different aspects of particle physics. Together, they act as gigantic cameras, capturing snapshots of these collisions. Scientists analyze the resulting debris for traces of the elusive Higgs boson, also called the God particle, and other phenomena that could provide clues to the fundamental elements of the universe. By studying the microcosm, we gain insights into the macrocosm. But with every discovery comes a new question, and each answer presents a new challenge. The LHC is more than just a scientific tool. It symbolizes human curiosity and innovation. It reflects our unyielding drive for knowledge and our desire to comprehend the fundamental forces that shape the cosmos. Yet, as we push the limits of our understanding, we must also consider the ethical and existential dilemmas that emerge. What are the potential dangers of probing the unknown? Could our quest for knowledge unknowingly unleash uncontrollable forces? At CERN, where the frontiers of human knowledge are relentlessly tested, a startling revelation has emerged, one that has sent a wave of unease through even the most seasoned scientists. Brian Cox, a former CERN researcher and a leading authority in particle physics, recently made an announcement that has both intrigued and frightened the world. Cox's statement resonated with an unsettling clarity. The aim of CERN's LHC is to recreate a mini Big Bang. Yes, you heard it right. A miniature version of the event that gave birth to our universe. He went on to explain the far-reaching implications of this goal, highlighting the LHC's extraordinary potential to make groundbreaking discoveries, including unveiling the secrets of the Higgs boson and investigating dark matter, the mysterious substance that comprises a significant portion of the universe. Imagine holding the power to create the very essence of the universe, to summon its fundamental forces. It's an alluring thought, but one fraught with peril. The mini Big Bang is no mere theoretical idea. It's a very real phenomenon within the LHC. The temperatures, the pressures, the immense energy, these all replicate the conditions present at the universe's infancy. It's as if you're standing at the dawn of time, witnessing the birth of existence itself. But with such immense power comes great responsibility, and the question arises, what if something goes wrong? In fact, something disastrous did occur back in 1978. Russian physicist Anat Borsky experienced a calamity that would forever change his life. While working on the U-70 synchrotron at the Institute for High Energy Physics in Pino, Russia, a malfunction caused a proton beam to pass directly through his skull. The beam, with a force that defies belief, entered at the back of his head and exited through his nose. What happened next was nothing short of extraordinary. Borsky saw a flash brighter than 1,000 suns but felt no pain. The proton's path through his body caused destruction, burning through tissue and bone, but he remained conscious, even walking to a clinic for treatment. The aftermath was both horrifying and fascinating. The proton's path left localized tissue damage, resulting in partial facial paralysis and loss of hearing in one ear. Yet, astonishingly, Borsky's intellectual faculties remained intact, allowing him to continue his scientific career. This tragic incident serves as a warning about the immense power and potential risks of particle accelerators. The dangers posed by a particle accelerator like the LHC are not to be dismissed lightly. The potential for unforeseen reactions and the manipulation of space and time itself are not the stuff of science fiction. These are genuine concerns shared by some in the scientific community. One of the most striking worries about the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions in space where gravity is so intense that nothing, not even light, can escape. They act as cosmic vacuum cleaners, devouring everything in their path: stars, matter, light. The idea that the LHC could generate such an entity, even on a microscopic scale, is both alarming and awe-inspiring. Could this black hole grow uncontrollably, eventually consuming the Earth from within? While scientists at CERN have assured the public that any black hole created would be unstable and would evaporate almost immediately, the very idea has sparked debates, fears, and a deep sense of awe at the vast power we are wielding. To understand how the LHC could potentially create a black hole, it's important to delve into the mechanics of particle accelerators. When protons collide at nearly the speed of light, the energy released is so vast that it warps the fabric of space-time itself. Picture a taut trampoline with a heavy weight dropped onto it. The fabric bends and curves, and if the weight is heavy enough, it could create a depression so deep that anything nearby would be drawn in. This metaphor simplifies what could occur at the LHC. In the world of quantum physics, where the laws of the universe are both strange and beautiful, there's a theory that suggests extra dimensions might be hidden within our reality. If these extra dimensions exist, the LHC's collisions could tap into them, creating a gravitational funnel that forms a microscopic black hole. This strange phenomenon has even piqued the interest of renowned scientists, including the late Stephen Hawking. In his writings, Hawking warned that the Higgs boson could become unstable at extremely high energy levels. This instability could trigger a catastrophic event known as vacuum decay, which could destroy not only Earth but the entire universe. Likewise, British cosmologist Sir Martin Rees expressed his concerns regarding CERN's experiments. In his book Discussing Humanity's Future, he explored the potential hazards of particle accelerator experiments, including those at CERN. His words were not just cautionary but laced with a sense of existential dread. He hypothesized a worst-case scenario where an ill-fated experiment could cause vacuum instability, resulting in a phase transition that could ripple through space-time, potentially causing a cosmic catastrophe capable of consuming the universe. While these concerns remain speculative, Rees assigned a probability to these catastrophic events, however low, suggesting that even a small chance should give us pause. The stakes, he argued, are incredibly high, and the margin for error is razor-thin. Scientists at CERN have conducted simulations and carefully calculated the risks, presenting evidence for the safety of the LHC. Even Brian Cox, a vocal advocate for CERN, acknowledged the importance of responsible exploration. He emphasized the rigorous safety protocols and reviews that are in place to ensure the LHC operates with utmost caution. Cox also reassured the public that the energies involved in LHC experiments are far within the limits of what Earth naturally encounters, and the chances of creating a stable black hole are astronomically low. Even if one were created, it would be so small and unstable that it would quickly evaporate, releasing a burst of energy, an event predicted by Stephen Hawking, known as Hawking radiation. This would be a fleeting cosmic event, a brief and wondrous moment, before it disappeared. Some have even speculated that the LHC's experiments could open a portal to another universe or dimension. While this notion is largely dismissed by the scientific community, it has captured the imagination of many, becoming a subject of fascination, fear, and even folklore. What might lie beyond our universe? Could we accidentally release forces or beings that we cannot comprehend? The idea of opening a portal to hell has even been sensationalized in popular media, adding fuel to the fire of uncertainty. But where did this idea originate, and how does it relate to scientific exploration? The concept of parallel dimensions is not new in physics. String theory, a leading candidate for the theory of everything, suggests that there could be more than the familiar three dimensions of space and one of time. These extra dimensions could be compactified or hidden from our perception, but could potentially be revealed under extreme conditions. Imagine the LHC as a cosmic key, unlocking doors that have been sealed since the beginning of time. When protons collide with energies never before achieved on Earth, they might tap into these hidden dimensions. The potential consequences of such a discovery are enormous, but, as with any frontier in science, there are risks and rewards. In conclusion, The CERN Large Hadron Collider stands as a monumental testament to the ingenuity and ambition of humanity in its quest for knowledge. It is a tool for unraveling the deepest mysteries of the universe, but it also serves as a stark reminder of the profound risks involved in probing the unknown. With each discovery, we inch closer to the edge of a vast, uncharted universe where the boundaries of science, ethics, and existence itself begin to blur. The question remains, are we truly ready for the power we are unleashing? CERN, the European Organization for Nuclear Research, has long been at the forefront of scientific exploration, particularly in the realm of particle physics. It operates some of the most advanced research facilities in the world, most notably the Large Hadron Collider (LHC), which is the largest and most powerful particle accelerator ever built. Over the years, CERN's research has significantly contributed to our understanding of the universe, and the organization continues to push the boundaries of science, uncovering unexpected phenomena that continue to astonish the scientific community. One of the most notable advocates for CERN's groundbreaking research is physicist Brian Cox. As a prominent figure in the world of science communication, Cox has made it his mission to bridge the gap between complex scientific concepts and the general public. Through books, documentaries, and public talks, Cox has made some of the most advanced areas of particle physics accessible to a wide audience, explaining complex topics with clarity and passion. Recently, Cox has been discussing some of the latest and most surprising discoveries coming out of CERN. These findings have sparked new debates, raised new questions, and in many cases, opened up entirely new avenues of research. What makes these discoveries even more intriguing is that they weren't anticipated by scientists, illustrating the unpredictable nature of scientific exploration and the excitement of uncovering the unknown. One of the most unexpected revelations from CERN's recent experiments is the detection of particles that seem to defy current theories. For decades, physicists have relied on the standard model of particle physics, which successfully explains the behavior of most known particles. However, the discovery of particles that behave in ways not predicted by the standard model suggests that there may be deeper layers of reality still waiting to be uncovered. For instance, during experiments conducted at the LHC, researchers observed strange interactions between particles that couldn't be fully explained by existing theories. These anomalies are pushing scientists to reconsider and refine their understanding of fundamental physics. According to Cox, such discoveries highlight the beauty of science, that it is not just about confirming what we already know, but about discovering the unknown. As new data continues to come in, the scientific community must be open to revising existing models and considering new hypotheses. Another aspect of these surprising discoveries lies in the behavior of antimatter. For years, scientists have been perplexed by the apparent asymmetry between matter and antimatter in the universe. While the laws of physics predict that both should have been created in equal amounts during the Big Bang, the observable universe consists almost entirely of matter, with very little antimatter. This imbalance remains one of the most significant unsolved mysteries in physics. Recently, experiments at CERN have begun to shed light on this conundrum. Researchers are investigating the properties of antimatter in hopes of understanding why it is so scarce in the universe. Using advanced technology to trap and study antimatter particles, scientists have been able to observe their behavior in unprecedented detail. Early results have indicated some intriguing differences between the properties of antimatter and matter, but much work remains before scientists can definitively explain this imbalance. For Cox, the study of antimatter offers one of the most fascinating puzzles in modern science, and its resolution could lead to major breakthroughs in our understanding of the universe's origins. Alongside the ongoing investigations into antimatter, CERN's research into dark matter has also garnered considerable attention. While scientists have known about dark matter for decades, its true nature remains elusive. Dark matter is thought to make up roughly 85% of the total matter in the universe, yet it cannot be directly detected because it does not interact with light or any other form of electromagnetic radiation. As a result, dark matter remains invisible to traditional observation methods, making it one of the most challenging aspects of modern astrophysics. However, experiments at CERN are beginning to offer new ways to probe the mysterious substance. The LHC has been used to simulate conditions that might give rise to dark matter particles, potentially providing clues about their properties. Though direct detection remains a distant goal, the results from CERN are offering tantalizing hints that could guide future research. Brian Cox has spoken extensively about the potential implications of these discoveries, noting that unraveling the secrets of dark matter could revolutionize our understanding of the cosmos and the fundamental forces that govern it.